Today, my presentation is about the knowledge proof for proxy encryption. So, my name is Momiyama, and this is my biography. So, through this program, I focused on verifying the validity of the public key by the knowledge proof. So, in case about the account abstractions, key recovery issues, this approach is very efficient, I think. So, So for now, about the social recovery in account abstraction is using the guardian, but this had a little bit the difficult thing about the social engineering or something. So we need to more uh, expand about the social recovery way by using the Web2 trust data, which we made an economic in Web2 internet system. So this system is very easy. So DKTS combined with the hard key verification is the realization of self-story in Web3. And also, this meaning that in Ocean, we make the proof about the uh, like kind of the uh, GitHub.com's their session, and we make a proof in the local and uh, using a TS notary or something, and um, we can propose a public input or proof to the bundle and use the operation member, and then we follow the ERC 4337, the account abstraction system, and we can use the recovery contract and the ZK verifier contract connect with the entry point contract. So such uh, such a concept is very easy to understand that in this case we want to prove that uh, GitHub profile page in the secret phrase and by using the public key uh, by using the by proof the valid public key we have combined with the GitHub account. So like this scheme, we can use the proof generation with the TRS notary and make a proof about the uh, this public input and this private input. And next, we verify the validity of the public key, this recovery key, this in other words, the recovery key. So this key is for the only valid who has the valid public key combined with Web2 certification. So this is only for the recovery key. So we can make a proof in the previous uh, DTS step, and we already have the proof and the word address and the temporary public key for the recovery and other translation for using the public key. And this is a contract implementation and save state by struct formatting from the old address to the recovery address. So this is the verification contract implementation. No, sorry, the verification contract implementation. And this is the address account ownership. So if we so after we finish the process of the verification of the public key, we do the uh, implement about the attached ownership. So uh, in client side, we can contain the new owner address and the same message with the temporary project key address and pass the signature data to the execute recovery function to switch the ownership. So this signature verification is like in general, we construct a message hash with exactly the same content as the message signed on the client side. So yeah, verify that the store the sign address matches the recovery address, and then the ownership update by using something like Discord, uh, this Discord, and yeah, if the change is valid, the contract update and the account owner information for the contract address. So actually, I'm sorry, I okay, it not worked on the interoperability problem, so this just skipped. So in the concept, in the based on the concept, I have the imagine for the database group for the proxy encryption system by varying the public key, uh, by the public key. So proxy encryption system is the yeah that's the secret key from the if the Alice encrypt something by using her public key. The proxy is reattach the decrypt person by using the request the public key and create a leak key. So what is the problem is that the public key is not verified in this process. So what is that by person or not is we cannot judge about that. So we need to vary this program by using the leaders or something to verify public key. So this is a very it is understand the way of the ZK PRE supporting encryption system. So first the valid is the public key for using the proxy encryption system, and then do this the leaky. So like yes, by doing so, Iris can judge that what the public key is valid or not. So, and what is important by realize the system is that end-to-end the on-chain, full on-chain, the decentralized key management. And I already developing this product by using the RWAO and the RWAV for the decentralized schema, decentralized storage. So this is a super easy product. So the proxy is a contract by uh, implementation about the yeah that's the secret key by using the key. This is actually special proxy encryption system. So this is the key fragment by instead of the key. So but the another thing is the same thing. So uh, this is what the feature is. This is for on-chain. So user can only access the local environment and the on-chain environment. So uh, combined with this product and the ZKPRE, we can do that varied person and we can we can just a varied person and we can delegate the legally attachment for the on-chain contract. So what it make is that we have the project safety in the authentication, just authentication and authorization with the KPRV. So if we do that, just as the KPRV, from one-time authentication is that efficient, but to using the ZKPRE to continuous and asynchronous authorization derivation because we can only do the judge is about just for this public key for the creating a wiki and but the data owner use his own public key by using the secret. So the ancestor is uh, only valid she's valid or not by using the his own public key. And we need to judge this by the next proof or something to realize that this public is valid or not. So by doing so, the one-time authentication given by the attestation for the public key can be the into the continuous and synchronous authorization derivation by the theory. So this is my interest and developing this protocol. And yeah, thank you for the program to get this visualization. So thank you so much.
Okay, from the which do you have do any anyone has any question? Beautiful presentation. So for example, if I want to recover my account using GitHub, so what should I do? So maybe the first step is to change profile or something.
Oh yeah. So in this case, I think about the secret specific phrase with your own, like my page lead me or something, and then you enter the your secret phrase by your brain, by your own brain, and also you get in the public key. Then you can make a proof and verify the contract like that.
Any other questions? Okay,